Welcome learners for the lecture 9 of a differential geometry. Today we discuss to the example of the parametric form of this equation, that is the surface equation for given to the sphere or their singularities, as well as parametric tangent plane at the surface normal. Then example will be given: obtain the surface equation of the sphere and find the singularity parametric tangent plane at the point and the surface normal. A sphere is the surface of a revolution of a semicircle lying in the XOZ plane about the z-axis. The curve meets the axis of a revolution of the 2 points. Then it will be given to the form: if point P is any point of the circle lying in the XOZ plane, its equation can be taken as to the form, that is the x minus a sine w, y equals to 0, and z considering as a cos u, where u is the angle made by the OP and the z axis u is called the co-latitude of the point P. Then after rotation through the angle V about the z axis, then let PM is a perpendicular line on this form of the equation. For the given figure, that will be given as a 3 axis, x, y, z axis will be generated. O point will be given as a center point, and first line will be generated to the that semicircle. P point will be considered. PM 2 points will be generated in this form. This P points is a considering x, y, z axis, and V points will be considering to the points that this is a U point considering as a 45U angle, and V points will be considering to the form, that is the XY. The XOY means the XOY will be considering to the plane, then XOM will be generated XOM. This type is called as a longitude of the point P, and it is V. Hence the position vectors of the P in the sphere is considering x equals to OM cos V, that is also called as a OP cos 90 minus U cos V, and they will be generated as this will be all called as a sine u, because cos 90 minus u equals to sine u. For OP is a will be given to the condition, and y will be generated OM sine V equals to considering to the form, that will be generated to the form OP sine W sine V, and Z will be considered a cos. Thus the sphere surface equation of the sphere is considering to the form R1 equals to a sine U cos V, a sine W sine V, and a cos W will be given as a x, y, z axis for the given to the condition, where u and v are parameters, and 0 is less than or equals to u less than or equals to pi, and 0 also be considering to the form, that will be generated 0 to 180 degree, and this will be considering 0 to 2 pi will be generated, that will be considering to the form in a 360 degree. For the v will be considering to the form. Hence we shall form to the find the singularities. Now R1 equals to a cos u cos v, a cos u sin v, and minus a sin u will be generated to the form. R2 equals to minus a sin u sin v, and a sin u cos v, and 0 will be considering the R2 form. Hence the matrix equation will be generated. First position a cos u cos v, a cos z, a cos u sin v, and minus a sin u will be considering, and m will be generated 2 points, that will be generated minus a sin u sin v, a sin u cos v, and next point will be considering as a 0. At u equals to 0 and u equals to pi, all the three determinants minors of a m are 0, so that the rank of a m is a 0. Thus u equals to 0, u equals to pi are a singular point. Since these singularities are due to the choice of a parameter, they are artificial singularities, because the same conclusion may be arrived to the considering R1 into R2 is also to the form. Second parametric curve will be shown. First, let us find to the parametric curve of the system u equals to constant when the co-latitude u is a constant. A cos u is a constant to the form, let it is a, then z equals to a is a plane parallel to the xok plane. If P is the point of the intersection of this plane and the sphere where u is a constant, then the locus of the points is considering as a small circle. Hence the parametric curve of the system u equals to constant is considering as a parametric parallel small circle, which are called as a parallel. When the longitude v is a constant, the plane of a ZOM is a fixed. The points P where V is a constant is the intersection of the sphere and this plane passing through the center of the sphere. Hence, the locus of the point P is a great circle. Thus, the parametric curve of this system is considering to the form V equals to constant is given to the system is a great circle is called as a meridian of the form. From first R1 into R2, R1 dot R2 equals to 0, so that the parametric curve are the ortho. Now R1 into R2 equals to a square I sine square u cos v plus j sine square u sine v plus k sine u cos v in this form. The equation of a tangent plane is a R minus capital R minus small r into R1 into R2 equals to 0. In the Cartesian form, the above equation given to the become capital X minus small x sin u cos v plus capital Y minus small y sin u sin v. In this both form will be considering, and capital Z minus Z cos v will be generated because third point will be given as a 0 equals to 0. Now H equals to R1 cross R2 equals to a square sin u. Hence capital N equals to R1 cross R2 upon H, that will be considering to the form sin u cos v sin u sin v and cos u equals to 1 by a into r, where r is the position vector of the point on the surface. So surface to show that to the where r is the position vector of the point on the surface, so that the surface normal is considering as a outward drawn to the normal.